Welcome to Fetching Data on Demand. By default, screen aggregates are triggered when the screen is initializing, and they run asynchronously and in parallel. However, that's not the end of it. In this unit, after briefly summarizing the screen lifecycle, we will introduce the fetch property of the screen aggregates and its two options, at start and only on demand. We will also talk about the impact both options have on the lifecycle. Finally, we will learn how we can trigger aggregates that are defined as only on demand. Let's start by reviewing the lifecycle of a screen. A screen must initialize in order to be accessed. By default, if the screen has some defined aggregates, they are triggered asynchronously and in parallel while the screen continues to build. When the screen is ready, it begins rendering. When the screen finishes rendering, the user will see some of the widgets that are part of the screen. Next, the first aggregate finishes and the screen renders again. The same thing happens when the second aggregate finishes. The screen renders again to display the new data. Aggregates are commonly used on screens to fetch the data that will be displayed to the end user. The widgets used to build the screen UI will have access to the aggregate's output data, allowing the developer to define the data to present. As previously mentioned, aggregates run asynchronously and in parallel by default, so there's no guarantee which aggregate will finish first. However, the default behavior can be changed. Screen aggregates have a fetch property with two options, at start and only on demand. Let's go through these two options. By default, all aggregates are created with the fetch property set to at start. This option defines the default behavior of the aggregates described earlier, where the aggregates are triggered automatically when the screen is initializing. This behavior promotes application efficiency since the screen continues to load and render while the data is being fetched, and when it's ready, it renders again to display the data. But in some scenarios, this behavior may not be the best option. Let's consider a simple screen that lists employees on the left. When an employee is selected, his or her details, including a picture, will be displayed on the right. Since no employee is selected yet, we defined the UI of the page to display a magnifying glass and a message. This list of employees has the getEmployees aggregate as source. Now we can click on an employee and see his or her details, which are fetched on the getEmployee picture by ID aggregate. In this scenario, the getEmployee picture by ID aggregate depends on the employee selected from the list, so it is not necessary or even productive to fetch this data at start when the screen is initializing. This brings us to the second option on the fetch property, only on demand. By setting the aggregate to fetch data only on demand, initializing the screen will no longer trigger the aggregate. With this option, the aggregate needs to be triggered explicitly in the application logic whenever it makes sense. To run these aggregates programmatically, we can use a refresh data element in a screen action flow, for instance. In this case, the aggregate will only run when the refresh data node is executed. That execution triggers the aggregate, which runs asynchronously as always. Whenever the data is fetched, the screen renders again to display the new data, and the on-after-fetch event still applies. Basically, the main difference is when the aggregate runs. Other than that, the behavior is exactly the same. Going back to our scenario, at start, the getEmployees aggregate would be running to fetch all the employee names for display on the list. When an employee's name is selected, an action triggers the second aggregate with the refresh data. When the data is fetched, the right side of the screen shows the employee info. For this, the aggregate would need to have its fetch property set to only on demand. Let's revisit the screen lifecycle with our example scenario. When we first access the application and the screen initializes, which triggers the Get Employees aggregate. Here, we already have the main difference from the first example, since only one of the two aggregates runs. The screen then gets ready and renders, and when the aggregate finishes, it renders again to display the data. Finally, when a user clicks on an employee's name, the onClick event executes an action that will trigger the Get Employee Picture by ID. When that finishes, the screen re-renders to display the new data.